In this video, we are going to learn about polynomials. We have studied about polynomials in our earlier classes. Here we are discussing some of the important properties of the polynomials. Now we are extending our vision towards the quadratic polynomial. Like we have studied what is a degree of polynomial. So if the degree of any polynomial is 2, then it is known as the quadratic polynomial. Now what is this degree? Let us recall what the degree is. As we have studied earlier what degree means, the highest power of the variable, right? If it is x square plus 4, now plus 2x c. This is a polynomial because it is having variables as well as the constants, right? So highest power of the variable is known as the degree of that polynomial. So if the highest power of any polynomial is 2, right? This is the degree. If the degree of any polynomial is 2, it is known as quadratic. Quadratic is basically square, right? Square, and square stands for 2. So this is how a quadratic polynomial is derived. If the degree is 2, then it is known as the quadratic polynomial. For example, this is the basic definition of a quadratic polynomial which I have discussed with you. Now see, the basic form of a quadratic polynomial is ax square plus bx plus c. It is ax square plus bx plus c. See, these are the coefficients, right? Whatever comes with the variables are the coefficients. So a is the coefficient of x square, b is the coefficient of x, and c is the constant. In this, if I am having 7x square plus 2x plus 3, so 7 is the coefficient of x square, 2 is the coefficient of x, and 3 is the constant. So these are the basic terms related to a quadratic polynomial. Now we'll move forward and see what is the zero of a polynomial, right? The value of variable for which the polynomial becomes 0 is known as the zero of that polynomial. Similarly, for quadratic polynomial, for cubic polynomial, for every polynomial, it is a universal definition of 0. 0 is that value of variable which makes the whole polynomial as 0. It is known as the 0 of that polynomial. See, for example, if you are having any linear equation, see, right? This is your linear equation because the degree is 1. So what is the 0? If I put x as minus 2, right? If I put x as minus 2 in this first equation, you will get it as minus 2 plus 2. Your answer will be 0. So this minus 2 can be said as 0 of polynomial, right? Because by putting this value of the variable, that is minus 2, I get the whole polynomial as 0. So this is my 0 of polynomial. Similarly, we have the geometric meaning of polynomial, basically zeros, right? What does this zeros means? See, if you want to see, this is your quadratic polynomial, right? The number of zeros for a quadratic polynomial is always 2. Why it is 2? Because number of zeros depends on the degree. If the degree is 2, then there will be 2 zeros. In general, for any quadratic polynomial ax square plus bx plus c, where a is not equals to 0, the graph of the corresponding y, that is this one, right? What is this y? What we are going to do, we are taking this whole as y and we are putting different values of x, right? We'll be putting different values of x here and we'll plot a graph. So this graph will be a curve, whether it will be an opening at the upward or opening at the downward. So these are known as the parabolas, right? Parabolas are basically an open curve. So this is a curve, it is a increasing curve, it is a decreasing curve. So these curves are known as parabolas. So we'll always form a parabola for a quadratic equation. For linear equation we used to draw a single line. For these type of equation which are quadratic, we'll always get a parabola. Now what does this parabola represents about the zeros? See, zeros zeros are that points on the graph where this y will cut the x, right? See this one, here you are intersecting here and here, so these are your zeros, so these are your zeros of the polynomial. Similarly, here you are intersecting here and here, so these two are the zeros of the polynomial. Okay, so these are the zeros of the polynomial where they'll be intersecting the x-axis. Okay, the points at which any curve will intersect the x-axis, these are known as the zeros of the polynomial. Similarly, if you are having a cubic equation, right, so if you are having curve like this, right, so this is your y and this is your x, and by looking at this graph you can say the number of zeros will be 1, 2, 3 and 4. So there will be 4 zeros for this polynomial. So number of zeros are the points of intersection of yx on the x-axis. Okay, so this was the geometrical meaning of any polynomial which gives us the zeros. Now let us understand the relationships between zeros and coefficient of the polynomial. Okay, so this is the basic generalized summary, like these are the basic rules or basic summary of any polynomial, right? The first is the quadratic polynomial and the second one is the cubic polynomial. There are few rules which are used for the verification purpose. So in general, if alpha and beta are the zeros of any quadratic equation where a is not equal to 0, okay, here a should not be equal to 0, because if a becomes 0, this will not be a quadratic equation. See, if a becomes 0, this will become a linear equation, so this a must not be equal to 0. Okay, then we know that x minus alpha and x minus beta are the factors of px, right? These are the factors and these are the zeros. Moreover, we can say that sum of zeros is basically equal to the minus into coefficient of x divided by coefficient of x square. Similarly, product of zeros will be constant term upon the coefficient of x square. Similarly, for cube, these are the basic generalized formula, that is we are having three zeros, alpha, beta and gamma. For cubic equation there will be three zeros, right? Because the highest degree is 3, so there will be three zeros. For this, you can verify the sum of the zeros should be equal to minus b by a, and the product like alpha into beta, beta into gamma, gamma into alpha is always equals to c by a, and all the products alpha into beta into gamma will be equal to minus d by a. So these are some generalized rules which you can use for the verification purpose for solving any sort of equation. अरे यार मैं record. Now let us understand this with an example. So these are some generalized rules. You have to just remember them for solving the equation, right? For example, if you are having a polynomial, right? See, this is your polynomial x square plus 7x plus 10. So this is your polynomial. This is your quadratic polynomial as the degree is 2. Now the factors will be x plus 2 and x plus 5. How you get that? Through middle term splitting, right? You get the factor as x plus 2 and x plus 5. Now x will be equal to minus 2 and minus 5. So these are your two zeros, right? So you can consider it as alpha and this as beta, right? Now what this statement says, sum of zeros, right? Sum of zeros is equal to the minus coefficient of x. Coefficient of x is 7 divided with the coefficient of x square, that is 1, right? See, this is your LHS and this is your RHS. Both are equal because this is minus 7 only. Minus 7 is equals to minus 7. So this says that your zeros you have calculated here, the zeros which you got here are true. Just this is just an verification process, like these two zeros are true or not, you can directly get it by this result, right? Product of zeros, see what is going to be the product of zeros, right? Product of zeros will be minus 2 into minus 5, and here you are having constant term, that is 10 divided with the coefficient of x square, that is 1. Here you get 10 equals to 10, that is LHS is equal to RHS, both are equal, so your zeros are true. Now let us see the division algorithm for polynomial. What does this division algorithm says, right? If you divide any polynomial, so this is your polynomial, that is 3x square minus x cube minus 3x, right? This is your, here we'll see the division algorithm, right? You know how to divide any polynomial. This is your polynomial. The polynomial will divide here, and then we'll justify this, or we'll just verify whether the division is true or not by using the division algorithm. So division algorithm is basically used to check your division, right, whether it's correct or not. It's just a verification, okay? It is basic not equals to 0. This g x must not be equal to 0, okay? So this is your px, right, and this is your gx, right? Okay, for understanding purpose I am marking it as px and here it is gx. From examples you can easily understand the concept of any algorithm, right? See, this is your 3x square minus x cube minus 3x plus 5, right? So this is your polynomial. So if you are going to directly do it like this, it is going to be a wrong process, because the very first step of division is to write the polynomial in the descending power of their degrees, right? So how you're going to write it as, see how you'll write. You will write this in the descending order. So the descending order will be minus x cube, right, plus 3x square minus 3x plus 5. So this is your descending order. Now you will divide it. You will write it as minus 3x cube plus 3x square minus 3x plus 5. And here you will write it as, again this is to be written in this descending order only, right? Minus x square plus x minus 1. So the very first term will be x, right? Because you will multiply it, you will get minus x cube. So you will multiply this, you will get it as minus x cube, right? Here you will get plus x square minus x, right? Now you will change the sign as positive, negative, positive. Okay, this will be cancelled because both having opposite sign. Here you will get the answer as 2x square. Here you will get the answer as minus 2x plus 5, right? Here you will write next digit will be your negative 2, right? Now you can write it as negative and negative, it will be positive 2x square, negative positive it will be negative 2x, and negative negative positive 2. You will write it as negative, it is positive, and here it is negative. Now you'll cut this and you'll get the answer here as 3. So this is your remainder, that is rx, right? This is your qx, this is your gx, and this is your px, right? Now for verification, it is given that px should be equals to gx into qx plus rx, right? So you can do it, right? It can be, px is written as minus x cube plus 3x square minus 3x plus 5. So this is your LHS, right? Now here you will solve your RHS. Okay, it will be minus x square plus x minus 1. It will be multiplied with qx, that is x minus 2, right? First you will do this and then you will add 3. By distribution you will multiply it, right? It will be minus x cube plus x square minus x. For minus 2 it will be minus 2x square, sorry, minus minus it's plus 2x square minus 2x plus 2 plus 3. You will get the answer as minus x cube plus 3x square minus 3x plus 5. This is your RHS. Since your RHS and LHS both are equal, so you have verified your division, both are equal, that means you are not having any error in the division. So this division algorithm, this basically this is the division algorithms help you to see whether the division you have done is correct or not. Okay, this completes your polynomial with all the topics. Thank you for watching.